Hello everybody. I'd like to introduce the two-way ANOVA test, the balanced design. Balanced design means that the total observation for each subgroups is the same. I'll talk about it once we solve the question regarding this subject. The two-way ANOVA here we have two independent factors, and for each of these two independent factors we have levels for each one. So for my presentation it will be 2 by 3, which means that we have two factors. The level for the first factor is 2, while the levels for the second factor is 3. So we have 6 group for the treatments. This is our question. An engineer expects that the surface finish of metal parts is influenced by the type of paint. So this is the first factor, type of paint used, and the drying time. And this is the second factor. He selected 3 drying times, 20, 25, and 30 minutes. So these are the levels for the drying time, and used 2 types of paint. So these are the levels for the paint factor. There are 2. 3 parts are tested with each combination of paint type and drying time. What is needed? Conduct the two-way ANOVA to test the hypothesis with alpha equal 0.05. The data are as follows. Of course, we need to conduct the two-way ANOVA by hand in order to understand all the details for this test. So for our question, we have 2 factors. The first one is the paint type. So this is factor 1. And the second factor is the drying time. So this is factor 2. For the first factor, which is the paint type, we have 2 levels. We have paint 1 and we have paint 2. So this factor contains 2 levels, while for the second factor, which is the drying time, we have 3 levels. The first one is the duration or the time, which is 20 minutes, and the second level is the time 25 minutes, and the third level is the 30 minutes drying time. And inside this table we have the records. For example, we have 3 metal parts. We used paint 1 and drying time for 20 minutes. And these are the records for the finish of the metal parts. So we have 3 observations in each subgroup. This is the two-way ANOVA table. which should be filled by all the calculated data. So for the case of two-way ANOVA, we have the sources of variation. We have the source of variation for the first factor and for the second factor and for the interaction between the two factors. And we have the error. We will calculate for the degree of freedom and the sum of squares SS and the mean square MS. And finally, we can calculate for the value of F, and we will determine the critical value of F and compare these two values in order to make a conclusion. So this is the contents of the two-way ANOVA table. First of all, let's understand the details of the question again in order to understand how to solve for the two-way ANOVA test by hand. As I have mentioned, we have the factor A, which is the main factor. It's called the main factor A, which is the paint type. And we have two levels, paint 1 and paint 2. So two levels means A equal to. So A1 means paint 1 and A2 means paint number 2. So this is the details for the first main factor, factor A, which is the paint type. Regarding the second factor, which is the drying time. So the drying time is the second main independent or second factor, and we have three levels for this factor. This is the first level, which is 20 minutes of drying time, and this is the second level, 25 minutes, and this is the third level, which is 30 minutes. So the value of B, which is the number of levels for the factor or the second factor, is equal to 3. So this is B1. B1 is the duration or drying time, 20 minutes, and B2 is 25 minutes, and B3 is the 30 minutes drying time. Regarding to the number of treatments groups, simply we multiply the two levels, A times B. A is equal to, we have two levels for A and three levels for B, so we have a total of 6 treatment groups. For example, this group here contains the records for the use of the second paint and the drying time for 30 minutes. And we have 3 observations because we have 3 metal parts, and these are the records for the 3 metal parts regarding the finishing of these metal parts. Regarding to N here represent the number of observation for each group, so we have a value of 3 for N. And if you notice that this value 3 is the same for all the groups of the treatments. So this is the meaning of the balanced design. Later I will talk about the unbalanced design in a second presentation later. And regarding to the capital N here represents the total number of observation. We have 6 treatment groups, and in each group we have 3 observation. So the total observations will be 6 times 3, which is 18. So these are all the details regarding our equation. Now let's start solving for this question by hand. First of all, we should state the hypothesis. In case of the two-way analysis of variance, we have 3 null hypotheses. For the first factor, which is the paint or paint types, we have the null hypothesis, which state that the finishing of the part by using paint 1 is the same as the average of the finishing by using paint 2. Or let's say mu for paint 1 is the same as mu for paint 2. So this is the first null hypothesis for the first main factor. Regarding to the alternative hypothesis, it states that the mean for the 2 paints is not the same. Regarding to the second factor, which is the drying time, the null hypothesis states that the mean for the 3 durations is the same. So mu for drying time T1 is the same as mu for drying time 2 is the same as the drying time 3. For the alternative hypothesis, it states that at least one mean is not equal to other. Regarding to the interaction between the 2 factors, the null hypothesis states that there is no interaction between the paint type, so we don't have an interaction between the 2 factors, the paint type and the drying time. Regarding the alternative hypothesis, it states that there is an interaction between the 2 factors. So as you see here, for the two-way ANOVA, we have 3 null hypotheses we need to test. So let's start with the calculation. First of all, let's calculate the degrees of freedom df. So first, for the first factor, which is the paint type, the degree of freedom for this factor simply can be got by number of paint types minus 1. And number of paints, which are the levels for this factor, is A, which is 2 minus 1. So 2 minus 1 is equal to 1. So this is the degree of freedom for the paint, for the first factor. Regarding the degree of freedom for the second factor, which is the drying time, the same, the formula is the number of drying times minus 1. So number of drying times is the levels for this factor b minus 1, which is 3 minus 1, and it is equal to 2. Regarding to the degree of freedom for the interaction, simply we multiply the degree of freedom for each of the two factors in order to get the degree of freedom for the interaction. So this is the degree of freedom for the first factor, it's a minus 1, and this is the degree of freedom for the second factor, which is b minus 1. For the first factor we have 1, and for the second we have 2, so the multiplication results in 2. Regarding the degree of freedom for the error, simply we can use this formula, a multiplied by b multiplied by small n minus 1. A is 2 and b is 3, small n is 3, which are the number of observation for each group. So 3 minus 1. So 6 times 2 is equal to 12. So simply we can calculate for the total degree of freedom by summing up the 1 and the 2 and the 2 and the 12. So we simply get 17 for the total degree of freedom. So now simply we can fill in the two-way ANOVA table with the degrees of freedom. So for the paint it's 1, for the time it's 2, for the interaction it's 2, for the error it's 12, and if you sum up all of these degrees of freedom you will get the total of 17. Now we need to calculate for the sum of the squares SS. Before start calculating the SS, we need to calculate the correction factor. We need the correction factor to calculate for other value like SS total. So the formula for the correction factor, it is simply the correction factor is equal to the total observations squared, total observation squared, we divide it by the total number of observations. So regarding the total observation, simply we need to sum all of the 18 observations, and then we need to square this value and then divide it by total number of observations, which is equal to 18. Simply you can use the Excel to get the total for the observation and get the square of this value. So the total observations is equal to 1322. So simply we should square this value and divide it by 18. So if you proceed, you will get the value of the correction factor to be 97,093.556. So simply in order to calculate the correction factor, you need to get the total observations and you square this value, then divide it by the total number of observations. Now simply we can calculate for the sum square for the total, which is SS total. The formula for the SS total is simply summation of the squared of the observation minus the correction factor. So we need to get the summation of the squared for all of the observations in our study. So the summation of the squared of the observations, we get 74 squared plus 64 squared plus 50 squared till you reach the last observation, which is 85. So this is the first observation in the table, it is 74. This is the second, 64. This is the third, 50. This is the fourth one. This is the fifth. This is the sixth. And the last one is 85. So you should square all of these observations in order to get the summation of the y squared. And again, you can utilize the Excel in order to simplify your calculation. So simply you will get the summation of the squared of the observation to be 101,598. So now simply we can calculate for the SS total. Simply subtract the correction factor from this value. So this is the summation of the squared of the observation, and this is the value of the correction factor, which is already calculated. So the value of the SS total is equal to 4,504.444. So this is the way how to get the value of the SS total. Now we need to calculate for the SS for each of the two factors. So let's start with the first factor, which is the paint type. This is the first factor, which is the paint type. So we have two types for the paint, and regarding the observation for the first type, these are all the observation related to the first paint type, and these are the observations for the second paint type. So if you sum up for paint 1, you'll get 621, and for the second type of the paint, it is 701. So as we said earlier, A represent the level of the first factor. We have two factors. So the summation for the first factor is 621, and for the second one it is 701. Notice that we ignore the drying time in case of calculation for the SS for this factor. So this is the formula to calculate for the SS for the first factor, which is the paint. Simply we sum up the total of the A sub I, and we have A1 and A2. So you should square the total of these two values. Okay, then you should divide it by B times N. B here represent the levels for the second factor, which is 3, and regarding to N represent here 3. So if you proceed, this is the summation for A1, which is the total observation for the metal parts by using paint number 1. We should square this value plus summation of A2701 squared divided by 3 by 3. 3 by 3 here is simply 9. You can understand from where the 9 comes. If we take paint 1, if you count simply here 1 and 2 and 3, which is N, and we have 3 and 3 and 3, which are the levels of the second factor. So we have 9 observations. So 9 in the denominator here represent the total observation for one of the paint type. And we should subtract the value of the correction factor, which has been calculated earlier. So if you proceed, you will get this value for SS for the first factor, which is the paint. It is 355.555. So right now we calculated for the SS total and the SS for the first factor. Now simply we can use the same procedure in order to calculate for the SS for the second factor, which is the time. And again, when we calculate for the SS for this factor, we ignore the first factor and the levels for the first factor. So the same technique, this is the formula for calculating the SS for the second factor, which is the time. First, we should sum up the B sub J, and J here represent number of the levels for the second factor, and we have J here equal 1, 2, and 3, and we should square this value divided by A times N. Then we should subtract the correction factor in order to get the SS for the time. So before starting the calculation in the formula, for example, this value in the table, these 6 values represent the summation of the first level of the second factor, which is the summation of B1. So the summation here is 434. Regarding the second level of the drying time, we sum up for these 6 observations. So the total is 437, And regarding the third level, which is B3, the summation is the total of all of these observations. So it is 451. Regarding to A times N. A times N here simply represent the number of observations for one of the three levels. For example, for the first level, if you count, we have this is the first observation, this is the second, third, fourth, fifth, sixth. So we have 6 observations. How we get this value 6? Simply we multiply 3 by the number of levels for the first factor, which is A. So if you proceed and substitute for these values, you will get the SS time. This is for the value for summation of B1, 434 square, plus this is for the summation for B2 squared, and this is the summation of the B3 level, and you should square it, divided by 6. And this value represents the correction factor, which has been already calculated. So if you proceed, you will get the final result for the SS for the time to be 27.45. So this is the way how to calculate for one of the main factor, and in our case, the factor is the drying time. Now, we should calculate for the interaction. So in order to calculate the SS for the interaction, which is the SS for the paint and drying time, as I have mentioned earlier, we have 6 treatment groups. For example, this treatment group contains 3 records, 74, 64, and 50. So the total for this group is simply the summation of A1 times B1. A1 here represents the first level of the paint, and B1 represents the first level of the second factor, which is T1. So the total here is simply 188. And if you notice that we have a number of observation to be equal 3. So this is the general formula to calculate for the SS for the interaction. First, we should calculate the SS for the subtotals minus SS paint, it's already calculated, minus SS time, and again it's already calculated. How to calculate for the subtotals? We first make the summation for each treatment groups, and here we have in the table to the right the summation for all of these 6 groups. The formula for the SS for the subtotal, summation of the treatment group, which is A sub I times B sub J. You should square this value, divided by the number of observation for each of these group, and notice that n is equal to 3. Then you should subtract the correction factor. So simply for A1, B1, the total is 188, and you should square it. For A1 and B2, these are the records for this group, and the summation is 178. So plus 178 squared, and you can continue the same technique, divided by 3 minus the correction factor. So this is the value of the sum square for the subtotals. Notice that this is not the SS totals, this is the SS for the groups. We have 6 groups in our experiment. So now simply you can calculate for the SS of the interaction. This is the SS for the subtotals. We should subtract the SS for the paints and the time. You will get the last value of the SS for the interaction. It is simply 1878.772. So this is the way how to calculate for the SS for the interaction. We should take into consideration the groups of the experiment. So we have 6 groups. You should sum up all the observation in each of these 6 groups, and you should square it, divided by the n, which is 3, and subtract the correction factor. So now simply we can calculate for the sum square for the error, which is the SS for the error. Notice that the SS total is simply the SS for the first factor plus the SS for the second factor plus the SS for the interaction plus the SS for the error. So all of these are known except the SS error. So simply we can calculate for the SS error by moving the other parts to the other side, so the sign will be opposite, and we can substitute. This is the SS total, this is the SS for the first factor, which is the paint, and this is the SS for the second factor, which is the time or drying time, and this is the SS for the interaction between the 2 factors. So the value of the SS for the error is 2242 plus 0.667. So by this way we have calculated all the SS for all the needed to fill the two-way ANOVA table. So right now we calculated for the degrees of freedom and for the SS for all of these sources. Now we need to calculate for the mean square, which is MS. It's very easy to calculate for the mean square. Simply divide the sum of square by the degree of freedom related to this SS. So to calculate for the mean square, MS, let's first start with the first factor, which is the paint type. So the MS for the paint, simply we divide the SS for the paint by the degree of freedom for the paint. So this is the value of SS for the paint, and this is the degree of freedom for the paint. So the result will be 355.555. The same way for the time. This is the SS for the time, and this is the degree of freedom for the time, which is the second factor. So this is the MS for the time. Regarding to the interaction, this is the value of the SS for the interaction, and this is the value of the degree of freedom. So this is the value of the MS for the interaction. Regarding to the error, this is the value of the SS for the error, and we have 12 degree of freedom for the error, and this is the MS for the error. So simply we can now fill in the mean square cells in the two-way ANOVA, same like what we have here. Now we can calculate for the statistic F, or the F calculated. It's very easy to calculate the value of F. We need to calculate for the F for the first factor, which is the paint, and we need to calculate for the second factor, which is the time, and we need to calculate for the interaction between the two factors, and simply you can get it by dividing the mean square by the mean square of the error, and the mean square of the error is this value, 186.889. So for the paint, the F calculated for the first factor, we should multiply the mean square for the first factor by the mean square of the error. This is the mean square for the first factor, and this is the value of the mean square for the error. So this is the value of the calculated F for the first factor. The same way we can proceed for the second factor, which is the time. This is the mean square for the second factor, and this is the mean square for the error. So the result will be 0.073. And finally, for the interaction, this is the mean square for the interaction, and this is the mean square for the error, and this is the last calculated value for the interaction. So we can fill all of these calculated values in the two-way ANOVA table. So the rest, in order to complete all the contents of this two-way ANOVA table, is to find the value of the critical F. And simply we can return back to the F distribution table, and you should notice that the value of the significant level in our question is 0.05. So in order to get the value for the F critical, we should know three values. The first is the significant level, which is already 0.05. And the second, we should know the degree of freedom for the enumerator. And the third one is the degree of freedom for the enumerator, which is the degree of freedom for the error. So in order to get the value of the critical F for the first factor, the value of alpha is 0.05. We should take the degree of freedom here 1 into consideration, and the other value of the degree of freedom is the degree of freedom for the error, which is 12. Notice that the value of the degree of freedom for the second factor and for the interaction are the same. So we'll get the same critical value for the time and for the interaction. This is the F distribution table for the probability of 0.05. In order to calculate for the paint first, we should take the degree of freedom 1 in the numerator and 12 in the denominator. So this row here represents the degree of freedom for the enumerator and for the first factor, which is the paint type, it is 1. And regarding the column here, this is the value of the degree of freedom for the error, which is the enumerator, and we have degree of freedom, which is 12. So the intersection between these two values, we get the value of F critical, which is 4.75. So the critical value for alpha equals 0.05 and degree of freedom for the numerator equal 1 and degree of freedom of the error, which is 12, it is 4.75. This critical value is for the first factor. Regarding the second factor and the interaction, we should take degree of freedom equal 2 and degree of freedom for the error is the same, it is 12. So the intersection here we'll get the critical value which is 3.89. So the value for F for significant level 0.05, degree of freedom numerator 2, and for the error 12 it's 3.89. This is valid for both the second factor, which is the time, and the interaction. Let's understand what we have got. This is the curve of the F distribution for degree of freedom 1 in the numerator and 12 in the denominator. And regarding the critical value of F, we have got it to be 4.75, and the meaning for this critical value is that the area to the right of this value, or right-tailed, is equal to 0.05, which is the probability. So the area here represents the value of the probability, which is 0.05. So this is the curve for the first factor, which is the paint. Notice that we already calculated the value of F. It is 1.93. And notice that the calculated value of F is less than the critical one. The critical value here divide the curve into two regions. The left region here, this is called the accepting the null hypothesis region, and the right region, it is the region for the rejection of the null hypothesis. So how to make a conclusion for the first factor? As you see here, the value of the calculated F lies in the non-rejection of the null hypothesis. So we conclude that there is no significance for the first factor, which is the paint, which means that the mean for the first paint is the same as the mean for the second paint. Regarding the second factor, which is the drying time, this is the shape of the F distribution curve for the second factor. Notice for this curve, the value of the degree of freedom for the enumerator is equal to 2, and for the error it is 12. So it will slightly be different from the previous curve. And regarding the critical value for F, we already get it to be 3.89, and notice that the area in the right-tailed to the right of this critical value is the probability, which is 0.05. And notice that we have two regions. This left region, we accept the null hypothesis. And regarding the left region here, we reject the null hypothesis. So as you see, regarding the calculated value for this factor, it is 0.073. It is deeply inside the non-rejection region. So we conclude that there is no significance for the second factor, which is the time, which means that we accept the null hypothesis for the second factor, which means that the average for the first drying time is the same as the average for the second drying time is the same as the average for the third drying time. Regarding to the interaction, it will be the same curve because this is belonging to degree of freedom 2 and 12. So we have the same critical value for F, which is 3.89. This region, we accept the null hypothesis in this region, and we reject the null hypothesis in this region. And regarding the interaction, the calculated value for the interaction is 5.026. It is greater than the critical value for F, and it lies in the rejection region for the null hypothesis. So regarding the interaction, we conclude that we reject the null hypothesis and accept the alternative one. The alternative hypothesis for the interaction states that there is an interaction between the two factors. So this is the conclusion for the interaction between the two factors. It's already mentioned here. So this is the calculated value for the paint. It is less than the critical one, so there is no significance. Regarding the second factor, it is 0.073. Again, it is less than the critical one, so there is no significance. But regarding to the interaction, the calculated value, which is 5.026, is greater than the critical value of F, which is 3.89. So in this case, we have a significance at 0.05 level. So this is the final conclusion for our question regarding for the first factor, which is the paint. The calculated is 1.903, less than the critical, so we accept the null hypothesis, which means there is no significance. Regarding the second factor, again, the calculated value is less than the critical one, so again we accept the null hypothesis and we don't have any significance. But regarding to the interaction between these two factors, the calculated value is greater than the critical one, so simply we reject the null hypothesis and we have enough evidence to accept the alternative hypothesis, which means that there is an interaction between the two factors, which are the paint and the time. So this is all about the two-way ANOVA. If you have any comments, please write it down and don't miss to click the subscription. Thanks and goodbye.